Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be looking at how we're going to replace CentOS and with what right after this. So this has been quite a bit of work, and I'm not done. I'm not done. So what I had hoped to do today was to go through the requirements, the analysis, the pros and the cons, and then get to the selection. Unfortunately, it's more work than I thought it would be. Of course, that's always true, right? That's always true. So what are we going to do here? So the way I approach a problem like this is I look at it from a standpoint of, okay, so we know what happened, right? CentOS is deep sixed, it's gone. So we need to come up with some goals. What is the goal that we're trying to do? And you need that for your organization because that is the thing that's going to drive the decision as to which distro you pick. The one I pick may be completely different from the one you pick. And that's all right. That's life. I mean, none of us have the same kind of applications. None of us have the same server needs. None of us have the same loads and all of that stuff. And then once you have the goals, usually what I do is then we'll go canvas and look for reference architectures in the industry that are similar to what I'm trying to do. And then I'll take those and I will look at them and I will create one of my own. And so that's what I'm doing today. And one thing I always think is funny in looking at reference architectures that in the modern day, it's all about marketing, right? So reference architectures are not a solution, right? They're just, hey, here's some components that you need to think about and where they kind of fit in the architecture. They're not, but today we start seeing products inserted into reference architecture. That's wrong. That's not how you do reference architectures. That's the way marketing people do reference architectures, not the way engineers do them. So yeah, I'm back up beating up on marketing people again. Sorry about that. So what comes out of the reference architecture? What comes out of it is a list of components. That is where we want to get to. We can play with the crayons all day long, and we can move the components around where they make sense, but we have to start with that, and that is to help us shape what do we need. And then finally, we start to write those requirements either in the form of formal requirements, if our organization requires that, not too many do anymore, whether we do storyboards or we start building up Kanbans or whatever it is that your organization needs to have in place in order to have a blueprint or some kind of roadmap of getting from where I am right now to where I want to be. So, yeah, and then I won't get that far. I won't get to write the server requirements, even though it says that I am going to write them. I will get most of them, but I won't have them formally defined. At least I don't plan to do any formal definition for this. I just want to know what things I need to make sure that the operating system has in order to support what I'm trying to do. So once you have all that, then you start doing the analysis on the replacement choices, and we already have those. And then what are the pros and cons for each of those candidate Linux distros in comparison to what I'm trying to do? We score it according to the priority, and I'll have the priority on here. So the next thing is from that, we build up a solution architecture and we see how it fits together. And then we start reading into it and doing engineering here to actually see if this component that I picked is going to fit talking to some other component that's in the mix. Maybe they don't even know about each other and there's no way for the communication to take place. That's when you have to start doing elimination. Now, solution architectures are never final. They, not until everyone gets through it. And you have to let the system engineers look at this. You have to let the developers look at this. You even have to let the testers look at this, because if they can't test it, then you can't sell it. So, and that's the way it goes. Also, you need to give it to DevOps, because DevOps has to install it. And they need to know, oh, I got to reserve this much time in order to get this thing set up and going. And so you need to get all those people involved. Sorry about that, but that's the world we live in. And if you are looking at external cloud, then What is the lead time for that, and what do they certify in their environments? You need to understand that. Finally, we get down to a choice of Linux distros. Maybe it's one, maybe it's two. I mean, it could be that maybe you don't have a single distribution that completely replaces CentOS 8. Maybe you have two of them that do it. We'll find out. So the goals. So here's some goals that I wrote down for me. So this is my goals, not yours. So what I want to do is, and you might see this kind of thing in corporate worlds today. So I did try to include some goals that you might find you're running up against when you're looking at trying to push a system design into an existing architecture. So I desire a flexible microservice-based architecture which can respond to changes in demand. Now, that's probably not a good goal. Why? I can't measure it. What percentage of the code goes over to microservices? So that's what we call hallucination. If I can't measure it, that one is. I left it in here because I want you to see that. So that's a hallucination. You can't measure it. So we can't do that one. We have to just eliminate it. But we can include that one in the design. We can say, oh, okay, so we're going to try to push for microservices in the design. All right, so I know I'll have some components that I'll need in order to fulfill that, but I can't measure that, so it can't be a goal. Desire to support a continuous integration, continuous deployment to provide new capabilities within 2 to 4 weeks. That one's measurable. I don't have to worry about all the details about the continuous integration, continuous deployment. What I need to know is if I come up with some kind of change, how long is it going to take to get it into the infrastructure? And my goal is to get it within 2 to 4 weeks. So the other one is the other one that's measurable is I want to increase server utilization to 50%. A lot of times in organizations, you have a lot of hardware that's sitting there 24 hours a day doing absolutely nothing. You'll see that all the time in private data centers where the load starts up at maybe, I don't know, maybe certain times of the day where it peaks and then it falls off for a while. So that server utilization doesn't stay constant. You want to utilize the servers as best as you can because that's where your money is going, right, into hardware, not to mention into people's salaries. So whatever you do in your design, you're trying to maximize that. I don't like to push servers up to their 70% capacity. And normally that is the capacity cap I put on a server because after that, performance just starts doing weird things. Latency starts creeping up in one place or it takes more time to get a database index read or something like that. Or an application service just can't get to your request in time before it times out. You just start seeing all kinds of weird problems when you start pushing up against the 70% level. So I don't like to push that hard. That gives me a little bit of growth. So I can add some more things to that server, but I need to get it up to at least 50%. That way I'm getting the money out of that server, right? So I desire to migrate 25% of the services to the public cloud. Now, maybe I'm internalized and I'm supporting everything and it's a pain in the butt and it's costing me a lot to maintain all this hardware that I'm not using. Maybe I should be looking at pushing some of it out to the public cloud because then I'm paying for what I use. Now you have to be careful because it's actually more expensive in a lot of cases to use public cloud than it is to use private. The difference is you aren't charged for it all day long. You only charge for it when you use it. So if you know that you can't reach the 50%, then your servers are basically idle and you're wasting resources. That's my point. So and then it is to desire to incorporate AI into DevOps. Now, that is, again, I can't measure that goal, but this is a prototype phase. What I'm interested in here is, can AI, this is a question, and it's a good goal, it's a question, can AI help with DevOps? Can it help out? Can it give the system admins information about what's going on in the servers and then what to expect if you have seasonal workloads or something like that in your business, then you can use the AI to help predict what's going to happen down the road. Now, there's a lot of other ways to use AI as well, but in this case, there isn't a lot going. I've seen some literature about using AI to help with DevOps, but this is really the starting year for when people are going, hey, what if we applied it to this? And a lot of developers are starting to use this to help write code too. So that's another avenue, another possible prototype that you might want to look at. So again, it's not measurable, so it's hallucination, but it is a valid goal to use as a prototype. Desire to contain cost to achieve a 1-to-1 ratio of money versus return. That's always the desired goal. In fact, they'll probably tell you they would prefer 2-to-1 return or 1-to-2 cost versus return. They would rather see that, but in most organizations, they don't even come close to 1-to-1. They're spending more than they're getting back on the return. And a lot of users today are beginning to question how much, we got all this stuff, how come I still can't get what I want? And that's still happening. It probably never will go away because users always think of things that was never planned. Another law. The desire to respond to server resources, server and resource overcommitment, meaning that maybe I have some SLIs, service level agreements or SLAs, and I have some indicators, SLIs, that fall within that, that say if it gets above 70%, let's say 7 milliseconds latency on my network, that's a bad thing. Or maybe if a database response time is under half a millisecond, that's a bad thing. So yeah, if I have things like that I can measure, then I can use this requirement as a valid goal, because what I'm really saying is is 60 seconds even a valid thing? I'm just throwing it out there. So I have a new server that stood up that can start handling the additional load once I start to peak, or I'm bringing in another virtual network in order to augment the latency problem that this congestion is causing. Now remember, one of the things that I've always known over the ages is that you have to be careful when you're looking at performance issues, because a lot of times the root cause is not the symptom. The symptom is usually something that's happened downstream as a result of something not doing its thing fast enough. I've seen a lot of times where services get so slow, the traffic backs up into the network eventually. I mean, it backs up into memory, it backs up into disk, and then it finally starts backing up into the network. You'll start seeing it maybe as a network latency problem, and you're going to think, oh, I need to just add more bandwidth. No, you get a problem upstream in that you're not able to handle the requests that are coming in. And adding more highways to handle more requests isn't going to solve your problem. So you have to be careful of that. So anyway, you have to look at this to see if it's valid, whether or not it's reasonable, is it obtainable, or is it just fiction, right? So from this, I then have taken, I have some major components that I now know based on what we've listed as goals that I'm going to have. Now, there's probably others, right? So, but these are the major ones that I've thought of when I was looking through this from the goals. And I've assigned which one of the goals is bringing that component in. So API, service registry, discovery, and mesh addresses goal 1. Deployment automation is goals 2 and 5. Now, there can be more goals that are in here that you have to worry about. So you may have components satisfying more than one goal. Application monitors, goal 3. Service monitors, network monitors, those are all goal 3. Network monitors also is infrastructure related, so that also impacts goal 7. Data storage, you need to look at that to see how many requests are coming in, how fast are they being serviced. And do I have enough? Maybe have metadata. And sometimes the clustered servers have metadata services. Some of them they have disk channels that are set up. Some of them have network channels that are set up between communication between the different servers. So you have to look at those things. They're all related to the amount of storage that's traversing your network and access times that are occurring. So yeah, you need monitors in that area as well. There may be other monitors you may be looking at. Maybe you have an LDAP or something, or an Active Directory service that's sitting on the front end on the login, and maybe it's providing Kerberos keys in the background to applications as they come up. So you also have to look at those kinds of things as well. So you may need measurement in place for the other types of the applications. So anyway, that's why these kinds of things are iterative. And you'll start to bring in more and more components as you start to delve deeper into the design. An architect's job is not to specify the design to the actual service level. An architect's job is to look at what components are necessary in order to meet the goals of the organization, and thereby meeting the needs and the requirements of the organization. Now, there are other requirements that are going to come in as well. We don't have those. Those would be business level requirements from the various groups within the company that are saying, well, I have a web service that needs this. It's an external web page and it does all these things. And so you've got to be able to provide this kind of service in this amount of time. Otherwise, it's a no-go for me. It's a non-starter. So you'll have to bring those goals and requirements in as well at some point. But I know what I'm doing with my system, but you may have external pressures that are going to direct how things flow in your organization that are different from the way I'm setting this up. Just be forewarned. Also, we have integration services, and that would be areas where I have different services that are talking to one another. I have different components within the infrastructure that need to exchange data, and how is that going to happen? Yeah, that's the miracle occurs here, but it can't be a miracle. It has to be designed. The services functions, those are the actual things that each of the services need to accomplish. And that helps the developers look at. Now, from an architectural view, I just need to provide some mechanism they can use, right? Some way that they can bring services into the mix and allow them to execute. I don't have to design the system for them. That's not my job, right? Yeah, I don't, in low-level stuff and architects, they don't get involved with. Sorry about that. That's the system engineers and the developer's job, not the architect's job. If you get to that point where the architects are actually designing the system for you, you're in big trouble. So anyway, update services, the OS level, applications and services, those are all under Goal 5. Update services have to do with security updates or application updates that need to come back into the system to fix a bug or some other problem, or maybe add new features. Also, there's services that are going to be coming in as well. What do you do with transactions that are currently in flight, and how do you deploy them without causing a cascade failure in your business? I've seen more than one time where services came in, were updated, and all of a sudden things didn't work, and you saw this cascade failure that went through the organization. You do not want that to happen. So you'll probably want to bring it up in stages on certain servers, but not all. Configuration management, you want to make sure that everything is configured properly and stays that way, doesn't get modified. I've seen too many times where we've had problems in operations where someone has gone in and made a change without testing it. And then all of a sudden you have a service that starts to crater because it doesn't understand what that particular change was. Or maybe it was just simply a typo. It could be a lot of things that happen. Humans, that's just the way things are with them. Utilization management, we need to look at from the standpoint of all aspects of the system. At this particular point, we also have service monitors and network monitors and all those things, individual things. But at some point, I need to look at the entire platform as a service, right? And see how it is performing in total. And so you need something that brings up a dashboard or something like that to give you a heads up as to where critical areas might be occurring in your system. That would be goals 4 and 6. Orchestration, yeah, since we have this goal of being able to get things up and running in 60 minutes when we hit some kind of peak load, then orchestration obviously has to fire off additional resources to help calm it down so that my system is maintaining its service level agreements, or the SLIs are being met. Also, IaaS, or infrastructure as a service. Performance monitors, you need those as well because you wanted to monitor the health of the servers in general. A lot of times those servers are going to be running more than one system. Either it's because they're virtualized or because there are virtualization and containers that are both deployed, and those can all impact the overall health of the server. Anyway, yeah, because you aggregate it up, right? A few best practices: automate everything, right? Use appropriate tools, make sure that they integrate well with one another and that they're not going to create security issues for you down the road. I know it's not always easy to test those things. But you have to do at least some homework to say, oh, I'm not going to. The worst thing you can do in any kind of infrastructure architecture is intermix applications with operating systems. That is a formula for disaster. And I've seen that so many times where somebody will they'll drag in something from Windows and they'll try to integrate it into a Linux environment, or vice versa. They'll try to drag something in from Linux and integrate it into a Windows environment. That just don't work very well. They do not play nicely together. So, they just don't. In my humble opinion, they don't. I don't care what anybody says. Now, maybe it'll get better with the Windows Linux as a service or whatever it is. But anyway, parameterize everything. The reason for that is that it allows you to be able to allocate your resources any way you see fit onto whatever servers are needed. And that allows you to move things like pointers and directories and mount points and all that stuff within the architecture without having to stop the app. That's the other side of it. Make sure that the parameters are dynamic so that if something comes up or if I make a change to the parameter, the application recognizes it or the service recognizes it and they can go ahead and use it. I know in the old days in Java, we used to have, these property files and you had to restart the application for that. That's just plain no. No. And if you have to use a database to hold your parameters, then do that. Whatever it takes to be able to do it. Don't rely on having to restart the server. That's just a bad idea. That counts against you. Encrypt the data at rest, data in transit, and data in use. Now that third one has been added on recently this year. But some people think that means that all you have to do is if the drives are online, it gets encrypted. If they're offline, they get encrypted. Like I encrypt the drive and I'm done, right? Wrong, because if that drive is mounted, it's effectively unencrypted because the operating system will unencrypt every file request that goes to that particular mount point. So that is not desirable, and that does not mean that satisfies the requirement for data at rest. It does not. Data being sent over the network is another one where they go, oh, wow, data in transit, it just means if it's going across the network, I'm done, right? No. Because data in transit could mean it's going through an iSCSI channel, or it's going over a fiber network to be pulled in from disk and into memory. So that has to be encrypted. It could be that it's sitting inside of a database. That has to be encrypted. So yeah, if you're encrypting everything, that's what it means. You're encrypting everything. I know a lot of people, they get lazy. They don't want to think about this stuff. I mean, but security is, if this data to you is really important, and if it gets into the wrong people's hands, your business will suffer in some way. But the other one is data in use. What does that mean? So data in use is not the idea around encryption on these different areas is that the worst exposure is the data at rest because all of it's available. The next step is data in transit because only a portion of the data that's in the organization is going to be flowing through the system at any one time, over the networks, into the application, over the fiber networks, whatever. Finally, you get down to even a smaller set of data, which is the data that's in memory. It's being used by the applications or the services. So, yeah, and if you're one of those people you think that if I just encrypt the disk, I'm done, you're wrong. That's not to be thinking about this. What else can I beat you up about? Nah, I'm just kidding. Other thing, maintain the least privilege on the system at all times. And that includes that you're probably going to have to set up groups for system admins, developers, testers, people that are responsible for maintenance of the system, because they will have to bring the system up to test if they replace something with hardware. So they may have to log in and check something, check the logs, make sure that device is now working again. So, and then finally the users. Yes, the users as well. So these aren't goals. These are mandatory design elements. These should be in there. And design, build, and run. That's a famous quote. Make sure you run away after you're done with all this. So anyway. So now that I have my components, I can start to lay them out. So I can get out the crayons and start chewing on the ends and working through a design from a reference architecture. And I will go and like I said, I will take pieces from other people that I consider experts in the field and I will draw upon what they use, but I come up with my own set because their reference architecture, as I said, is going to be marketing driven. They're trying to sell me their product, right? But I'm not interested in their product, but I am interested in including making sure that I haven't forgotten something in the design that maybe they thought about that I didn't. Always good to have more than one eye doing it, and then you want to float this to your system engineers, your developers, and even the users. They may not understand it, but they'll want to look at this and say, we have this other system over here that we want to be able to use on the outside. We need that pulled in as well. So from the bottom up, hardware, and that could be running in a public cloud, a private cloud, or in it should say, I just copied it across. It should say the private data center. Operating system and then observability, that's your performance analytics that are being collected from all the different nodes and knobs that are in the system collecting data that you want to know about. Distributed scale out storage would be above that because it might even be below observability. But so those are areas of debate where you put things, is because I always put observability near the operating system because I tend to use BPF in order to do the observability functions, which is inside the kernel and not inside a user space. Virtualization and containers next, orchestration above that to be able to orchestrate all aspects, the hardware, the virtualization, and the containers. Databases above that. I don't know if you have SQL databases or non-SQL or just some Hadoop type stuff. So you might have that. I consider that all valid databases. Machine learning and analytics would sit above that. And then finally, and whether or not you're using machine learning or analytics for your application, this applies to DevOps because you're trying to learn what aspects of the system is being used. So you may track on the observability database. You might look at the error logs. You might look at things like frequency of the application coming up and going down, which would mean that it's coming up and then maybe it dies off after a while because it's idle. And then you'd have microservices. Again, that's a goal for this particular thing. We have some layer, and then for serverless platforms, which is kind of a modern way of looking at systems today, even though they're not truly serverless. Integration services and API, I hate that word. Service description is probably more apropos. APIs to me are just too inflexible. I hate them. I just have never liked them. They are usually a cause for, well, we can't change that system out because it has this API that only this other program works with. And then you end up with this whole chain of junk that you don't want. That's why I don't like them. Web apps, mobile apps, desktop apps. Now, mobile apps arguably are in the old days, we used to think of mobile apps as just being a different way of presenting web traffic. That isn't true today. I mean, so a lot of organizations have applications that actually run on the phone. So that's incorporating the mobile app from that standpoint. And then finally, identity and access management at the top as the first line barrier, or actually the front line barrier between your system and the edge. There'll be other barriers between you and it, but that's the barrier of access in. You may also extend that downward into the servers and the services, into the services if you're using things like SAML, for example. AI flow is a little bit different because what I was trying to see here is is there something, now this isn't mine, this belongs to D-Zone, and D-Zone has a very nice write-up on AI flow for DevOps because they happen to have, I looked for one that didn't have their product in it, so it was more generic and it looked like a possibility that this is kind of the flow that AI goes through. There's some kind of data engineer and some kind of data scientist that looks at the data and determines what kinds of things are measurable, what kind of models will run on it. And then you look at things like what's the success rate for test against this particular comparison that I'm doing. Maybe it's between two fields to see if there's a correlation. There's some validation and optimization that goes on there in the training exercise, and how well does that training work in identifying a particular set of use cases out of it. So, or a particular set of data out of the training data, or even a larger set that sits outside the training data to see if the AI is picking the right result most of the time. And so this was a pretty good flow. I think kind of typical. There's a lot more steps than this, of course, but I thought it was pretty good. So, next thing, I got to think about requirements or something in order to group these things together, because not all people in an organization work on everything. So you may have database specialists, you may have data scientists, you may have data engineers, you may have network engineers, you may have security engineers that you're handing this stuff off to do, and so, or help you design the requirements for it. And so, but that again is not an architect's job. That's the system engineer's job. It's his or hers responsibility to look at those things and start to assign the work out to the different groups to start collecting in the goals or whatever, the Kanbans or the storyboards or whatever your organization uses. So finally, I broke it down into DevOps support. Obviously, if in a CI/CD, if you don't have DevOps support, then you missed the boat. The bus went by. Common services for the cloud. Chances are, because I have a goal to have 25% in the public cloud, I'm going to need common services for that. And those are integration points that I'll have to be able to meet, whatever cloud provider is doing things for me, in order to make sure that the SLI and the SLA that they agreed to is being met. Distributed storage, scale-out storage, you need that for the apps to remain mobile and the containers to remain mobile, so that you're not tied to a particular piece of hardware. That would be bad if that happened and your server went down and you were depending upon a certain type of interface or a certain type of storage cluster that was nailed up on that machine, and you went to a machine where it didn't exist, your app wouldn't be able to run. So that's why you'd want distributed and scale out. Distributed being if something were to happen weather-wise, for example, or maybe it was a geologic event of some kind, earthquake or whatever, that a particular site, the entire distribution center was down for some reason. Maybe got hit by a hurricane and it flooded with water. Something like that could happen. Then distributed storage allows you to switch operations to a data center which is across the country or a different country site across the world. Web app support, web services support, obvious stuff. Artificial intelligence. Now, this isn't, you don't normally have, now you do have some model validation that happens in production runtimes, but you typically don't do the training in production. You may run error analysis out in production to see, hey, I got a problem here. This isn't responding correctly, and I need some data before I can ship it back to the developers to look at. But typically at this point, you're looking for things like in machine learning. You might be looking for pipelines and how those are being distributed. You might be looking at TFX or TensorFlow and those type of things, and how you can get either Kubeflow or Kubernetes to orchestrate additional resources if you need those to scale up to make the AI more responsive. Maybe it's just getting flooded and it's just being drowned in requests. Containers and virtualization, same thing there. You're looking at orchestration for those in order to maintain SLAs and SLIs. Security compliance, I think it was Anto, I think asked about GDPR. And so those are all security compliance, and those rules, I looked at it, was 11 chapters. Well, that's enough to bury you in any kind of a problem. They could definitely bury you after reading that. It's pretty scary, actually. But the good news is there's a lot of security compliance software that deals with that. And so Linux on its own merits, if you just nail up a Linux distro, it is not going to be compliant with any security standard, whether it's PCI DSS, whether it's HIPAA. It's not going to be compliant at all. Those are things that the hardening, the security compliance audits have to look at. And also, you need to design for those things in advance. If your systems aren't designed for that, then you're going to end up retrofitting them into an existing system, and that's not always optimal. So security compliance is something that you don't run once until you get a good answer and then say, I'm done, either, because things are dynamic in your infrastructure and can change and throw you out of compliance without you being aware of it. You don't want it to get to court by the time you find out that you're out of compliance with whatever security guidelines you are mandated to support. So my advice there is that you make security compliance part and parcel to the early architecture of your system. And I know there's a lot of people today that don't like that. They don't want to do that. Those people are probably headed to be broken into, have their data encrypted, or being sold off to other companies based on proprietary data that they are able to exfiltrate from you. So I don't know what that's worth to your company, but you need to write it down on paper and figure out what that is worth besides your own job, because if you're responsible for that and you fail, I guarantee you'll be, if in some of these instances, some of these compliance standards, you will go to jail. If you're convicted, you will go to jail and pay a hefty fine. It won't just be the corporation. They can't protect you because these laws are written. They will go after you. So anyway, order of execution priority in order to stand this up. Order of battle, as we said, is that what do I need to do first? What's my priority? What I got to get down in the infrastructure first in order for this all to work? Well, obviously I have to have containers down first, or virtualized platforms, in order for everything else to hang off of. So that's priority number one. Second, I need a way to make sure that the developers, the testers, and everybody can get the changes in and out of the system. That's second priority. Once I have the infrastructure up to support it, I need to have at least start to bring in the CI/CD elements in order to support the transition phase from going from development to test, and then test to production. Maybe you have an integration server in between. Maybe you have a compliance audit you have to do in between. Whatever those mechanisms are, production being the last place where your application development is done. Orchestration and applications definition, you need that stood up early, because that's part and parcel to how the containers are brought up and what order they're brought up in and where they're brought up in order to service the system as a whole. And so I put in here a question which you might want to know in your requirements, which Linux distros are certified for Kubernetes, if that's your pick for orchestration. So, or whatever it is in that particular stack. So IIS performance and analysis, which Linux distros are certified for TensorFlow or TFX? I need to know that, right? Some of them are, and some of them are not. Some of them don't even have TensorFlow as a part of their application set. So service proxy, discovery, service mesh, that could be a microservices architecture. It could be SOA. I hope not. It could be even just a basic web services architecture. So again, you need to look at the standards that your organization has for those and make sure that the Linux distro that you're looking at has the ability to support whatever your organization currently uses as a standard. Second, network and policy security. What are the compliance standards for your network? What's the policy on what is allowed in and out? Law. We had all these. What laws are you liable if you break? What are you in trouble for if something gets through and data gets exfiltrated? I'll be right back. You might want to know about databases and distributed storage, what databases are being used in your application. Maybe you're in partnership with another organization. What standards do you use to exchange data? What other data is needed by applications and services that are hosted on this platform? Also, I always put streaming and messaging together. I'm not talking about video streaming here. I'm talking about data streaming. That is a pretty popular way to move data around today because it doesn't require the extra I/O of having to do a lookup on the file. If you know that you have telemetry that you're collecting off of, maybe it's data telemetry that's flowing to DevOps, the best way to do that might be a stream where it's just coming constantly and updating your information systems windows in real time, or as close to real time as you can get. Messaging is formal, like requests and exchange of data. Container registry, container runtimes. I need to know what containers I have, what ones are running, what they need when they're running, all of those things. And usually those are things that are documented or created as part of Kubeflow or Kubernetes. You can do it even in Docker Compose to some degree. OpenStack has Zune, I think it is, that does that particular layer. Although I think, that does some of that. I don't know how well Zune does it, but I know that there is a component inside of OpenStack that does some of that. And virtualization, what Linux distros are certified. Also, what container runtimes and registries are certified by your Linux distro. What Linux distros are certified to support your virtualization platform. So I think Zen has some. And I'm pretty sure that you don't have much of a choice on Proxmox. On which server platforms you can use. So Zen's going to be interesting, isn't it? Because it's CentOS based. Yeah, that's going to be interesting to see what they do there. So I'm not going to write formal requirements for this because that's not a job of an architect. That's the job of the end user, the system engineers, and the developer team to write those if you're in that kind of an environment. But I will put together a solutions architecture. An architect always does that. They create a draft, they circulate it. It goes with the people developing the requirements. They use that to help shape requirements and fill in gaps that they might need. They also will bring back updates to you for things that they need in the solutions architecture that were not included. So, and you will update that and circulate it back out to all the other groups again. That's your job. If this solution architecture is then completed, then it moves on to the build phase. But and it's approved by the user, it's kind of an important thing to have them approve it. If they don't approve it, then what are you building the system for? Who are you building it for? Just an exercise to do something in the lab or what? But so for me, the solution architecture is going to define which distro to use, because at that point, I'll know the pros and cons of each and be able to then say, definitively for this particular exercise, this particular distro will be the answer. Now, it's going to be different probably for you because you're probably not doing the same things I am. And so next time we'll start to delve into that. And that's okay. I mean, that's life. Nothing's the same. If it were, none of us would have much to do. We could just cookie cutter systems all day long and be done with it. Anyway, hope you enjoyed this. And if you did, please like and subscribe. Hope to see you all again real soon. And if you guys can come up with some things that maybe I've left out that you would be interested in including, let me know. I mean, this is probably going to take a while to get through all of this. I'm not in a hurry to do it. I wanted to get through this front piece because that's really the building blocks on which I need in order to go, I need to ask some questions and look into these distros. Which questions should I ask? So, that's kind of important. Anyway, hope to see you next time. Bye for now.